far. Last time we learned there's two main types of sequences, arithmetic and geometric. And there's other types, but these are the two main types. It's going to show up again and again and again. Which one was a linear function? Yes, arithmetic is a linear function. What type was geometric then? Exponential, good. Exponential. Okay, and then we learned how to write the equation or the rule that they follow. So they both had an AN, which is like a y equals. Okay, and then for arithmetic, we had our starting term, A1, plus, and then in parentheses, there was n minus 1, which is like an x minus 1. And then what was behind it? D, common difference, right? Times the common difference. And then for geometric, we had the AN, and then we had the A1, which is the starting term, times the common ratio, which was the R value, to the power of n minus 1. Which one was the one that I said we did not have to simplify? Geometric, right. All right, and then last time we talked about how to find the sum of series. And the way we talked about it last time was we found each individual term and then we added them all up. That would be super labor intensive if there were a lot of terms. Like say you had to add up 50 terms. Like that would be super annoying to have to go find all 50 of them and then go back and add all 50 of them. So for arithmetic and geometric series, there are formulas that you can follow. Instead of having to find all the terms individually. And this only works for arithmetic series or geometric series. So starting with the one for an arithmetic series, partial finite, so it's not like an infinite series that goes on forever. Partial series means that it just has an ending point, it stops. So looking at that formula, sum of the first however many numbers you're trying to find equals N stands for the number of terms. Number of terms. Okay. A1 stands for the starting term. Starting term. And then AN stands for the ending term. Starting term, ending term. Okay, so the first two we've got are written in summation notation, which we kind of talked about last time. So we'll have to interpret the summation notation into what we need to plug in to our little formula here. So looking at the first one, this summation notation says we need to add up the first term through the 20th term. And I can tell this is arithmetic because this is a little linear function here. So first through 20th term of the series that follows this rule, 4 plus 3i. So the things that I need to find n, which is the number of terms. I need to find the starting term, which if we look on the bottom, my starting term would be my first term, A1. And then I need to find the ending term. So if I look on the top is the ending term. So I need to find my A20 also. So starting with number of terms, 20. Yeah, the first through 20th term would be 20 terms. 20 terms. Okay. First term, how do you think we're going to find the first term? Plug in 1 to this little arithmetic rule we have here. 4 plus 3 times 1, my first term is 7. Good. And then my 20th term, my ending term, would be 4 plus 3 times 20. Good job, that is 64. Okay. So we know everything to plug in now. So this would be called the 20th partial sum because we're just finding the sum of the first 20 numbers. So sum of the first 20 numbers equals, and then we'll put the number of terms divided by 2, and then we'll put our A1 plus our A20, 7 plus 64, and then we'll just simplify that. So sum of the first 20 numbers would be 10 times, what's 64 plus 7? 71. So then that would be 710 for some of the first 20 numbers. Yeah, not bad. It's nice not having to find all 20 of them and then go back and add up all 20 of them. That would be a pain in the butt. Looking at the second one, what's different about it?
It starts at 0.
It starts at the 0th term. Very good. So when we think about our starting term will need to be our A0, not A1, but A0. So we'll still need to find in the number of terms we're going to be adding. We'll need A0, which is our starting term, and we'll need our ending term, which on the top is the 28th, so we're going to stop at the 28th term. So if it's 0 through 28, as Danny said, you're not adding up 28 terms, you're adding up 29 terms, because 0 would add one more term. 29 terms. Okay, our starting term again is going to be A0, so we're going to plug in 0 to this little function here. -2 plus 4 times 0, which means my starting term is -2. Good job. Okay. My ending term would be my 28th one according to the summation notation, so that would be -2 plus 4 times 28, which is 100 and what? 110. Okay, so we have the 3 pieces of information we need in order to use our formula. So now we're going to go and find the 29th partial sum, because that would be the sum of 29 numbers. Sum of 29 numbers would be 29 terms divided by 2 times the 0th term through the 110. Sorry. -2 plus 110, which would be 14 and a half, not 14.8, 14 and a half times 108, which Mason said is what? 1,566. Good. Okay. The 2 on the bottom, kind of just saying it a different way. This one is not written in summation notation. This one is just written in normal series notation. You know it already? No, we don't have to write it in summation notation. So remember the things we need to find the formula. We need to find the number of terms. Okay. We need the A1, which I can actually see in the sequence, and I need the AN, the last term, which again we can see in the sequence. Okay, so we have to really figure out like what term number this is, because this is I know my AN is 34. I just don't know how many numbers I'm adding up to get to 34. So there's different ways you can do it. You could use your common difference and use your A1 and like use your arithmetic sequence formula. Like you could use this. You could also just kind of figure out the common difference and then figure out, like, just keep adding until you get there. What I'm going to do to find what in this is, Alright, I'm going to take my arithmetic sequence formula, A1 plus n minus 1 times my common difference. And I'm going to basically plug this in for the y, which is the AN, and I'm going to solve for its x, which is the n. Okay, so I'm going to put my 34 where AN is. I have my A1, which I can substitute in. It's -1. Plus, we don't know the n, that's what we're trying to solve for. And the common difference, we can actually just look real quick. It is adding how much each time? 5. Very good. So we can solve this for n. 34 equals -1 plus 5n minus 5. So that would be 40 equals 5n. Good job, Mason. So that means n equals 8. That is the 8th number in the sequence. Alright, now that we know that's the 8th number in the sequence, we have everything we need to know to find the sum, because n is the number of terms, so we know it's 8 terms. We know our first term is -1, and we know our last term is 34. So we can plug everything into our sum formula. This would be called the 8th partial sum. There's just sum of the first 8 numbers. Equals number of terms divided by 2 times the first plus the last. So negative 1 plus 34. So that would be 4 times 33, which means the sum of the first 8 numbers is 132. Good job. Okay. Anyone looking at the next one already? Trying to figure it out? You already looking at it? Okay. So on the bottom, we've got, okay, we're starting at the first term. We're going to the x term. So we don't know what term we're stopping at. We know it's arithmetic. I can tell by this little linear function here that it's arithmetic. And we already have what the sum is. We already know the sum is 440. Okay. We can use the sum formula for this. So I'm going to write down my sum formula. N over 2 times starting plus ending term. Okay. For my Sn, what am I going to plug in? 440. We know the sum already. Very good. 440. Okay. For my number of terms, technically we know it. What is it? Yeah. No. X is x. X is the number of terms. 1 through x would be x amount of terms. So I'm going to have x over 2. Okay, and then my first term, we can find the starting term. 2 times 1 plus 1. Very good. It would be 3, so we can plug that in. Okay. And we can technically find the ending term also. The ending term is just going to have an x in it. So my ending term would be a x. And just plug in an x, so it would be 2 times x plus 1, which is just 2x plus 1. It's just 2x plus 1. So we're going to plug that in for an, 2x plus 1. Okay. Let's see what we can do to simplify. Yeah, you can multiply by 2 and get rid of that fraction. So it would be 80 equals x times, if I simplify in that parenthesis, I would get 2x plus 4. Then what? Distribute the x. Good idea. That at least gets rid of the parenthesis. 2x squared plus 4x equals 880. What type of equation is it? It's a quadratic equation. To solve this, yes, we can set it equal to 0. Disgusting. So we'll have 0 equals 2x squared plus 4x minus 880. Definitely divide by 2 to make those numbers smaller. So it would be x squared plus 2x minus 440 again. Do we think it's factorable? It totally looks factorable. We'll just need 2 numbers. I gotta multiply to negative 440. I gotta add to 2. Everybody's grabbing that calculator. Yes, 22 and negative 20. 22 times negative 20, it does multiply right. It does add right. Very good. Okay, so we'll get x plus 22, x minus 20. Taking each one, setting it equal to 0, and solving it will give us, what's my first solution? 20. Okay, well, let's think.
Well, it has to be 20.
It has to be 20, right. Remember, when you solve a quadratic on a word problem, you often will get an extraneous answer. And which one of these numbers wouldn't make sense for how many numbers we're adding up? Negative 20. You can't add up a negative amount of numbers. So this one would be extraneous, which means we'd only have 20 terms. Wasn't that fun? What? I thought that was so much fun. Did you enjoy it, Erica? Did you enjoy that? All right. Geometric. Okay, so pausing on arithmetic. Geometric, remember, these are the ones that follow an exponential function pattern. Let's see if we can break down this formula here. This is only if they're geometric, only if they're partial, meaning you're adding up like a specific number of terms, not just one going on to infinity. We got our Sn, which is just your sum. We've got our A1, which is your starting term. So remember, if you start on the 0 term, then your A1 will be A0. Starting term. We have R. What's R again? We had R last time. Common ratio. That's how much you're multiplying by each time. Common ratio. And then we have N. N is just how many terms you're adding up. Number of terms. What does this one not have that the last one did? Feel free to flip back. Ending term. It doesn't have ending term, right? Which is kind of nice. Alright. First two are written in summation notation. We can tell they're geometric just based on this right here. This is these are both exponential functions, so I can tell these are geometric sequences. The common ratio is always the base of the exponent. So on this it would be 3. On this one it would be 3/2. Okay, looking at it. First one, in order to find the sum, we're going to need to know our A1. We're going to need to know our common ratio, and we're going to need to know how many terms we're adding up. Okay, so my A1, we can find that just by plugging in 1 to the little geometric sequence here. 4 times 3 to the power of 1 minus 1. That would be 3 to the 0 power. What's 3 to the 0 power? 1. So that's 4 times 1, which is 4. Common ratio is going to be the base of your exponent. So on this one it would be 3. And then number of terms, if we're adding up the first through the 16th, how many terms am I adding up? 16. Okay, plugging into my formula, sum of the first 16 numbers equals our A1, which is 4. And then we'll have a big giant fraction. On the top of that fraction, we'll have 1 minus the common ratio to the power of 16.
That's a big number.
I know that. God bless calculator.
And it's a negative number too, because it's 1.
And on the bottom, we'll have 1 minus just the common ratio. Alright, I'm grabbing my calculator. This would be a great one. Y'all know the fancy fraction where it stacks it real nice and cute for you? This would be a great one to use the fancy fraction on. Just so it keeps it looking clean. If you don't remember how to get the fancy fraction where it stacks it one on top of the other, ask the person in your group. I bet someone else knows. Okay, everybody getting it typed in? Erica, you got yours typed in? Woo, yep. 86,093,440 is the partial sum. Now that is a great one where we have to say thank you that we didn't have to find all 16 of those and then go back and add all 16 up. That would have been a messy paper. 86,093,440. Make sure you're able to get that. If you're not able to get that, ask someone in your group, hey, what did you type? I didn't get that on my calculator. Ask for help if needed. Bless you. Okay. The next one, what's different about this one? What's our starting term on this one? 0, right. So when we think about starting term, we're not going to be using A1, we're using A0 on this for our starting term. So we'll have to find our A0, we'll need our common ratio, and we'll need the number of terms. To find A0, you can just plug in 0. 4 times 3 halves to the 0. Anything to the 0 is 1, so this would just be 4 times 1, which again is 4. Are they always going to be 4? No, just a fluke. My common ratio should be the base of my exponents. What's my common ratio on this one? 3 over 2, or if you want to write it as a decimal, it would be 1.5. However you prefer to type it. And the number of terms, we're starting with 0 and going to 6. That number of terms would be 7 terms, right? Yeah. Okay, let's see. Sum of 7 terms will be 4, that's my starting term, 1 minus my common ratio to the power of 7 over 1 minus the common ratio. Notice how I'm always writing my common ratio in parentheses. I feel like there's sometimes where you'll get the wrong answer if you don't put in parentheses, so I'm just always putting it in parentheses. I don't remember if it happens with fractions or decimals or what it was, but there was one situation where people wouldn't get the right answer if they wouldn't put it in parentheses. 1 minus 1.5 to the 7th power over 1 minus 1.5. Alright, as a decimal, did y'all just give you a decimal or a fraction?
Give me a fraction, but you can just change it.
Yes, okay. 128.6875, or as a fraction, 2059 over 16, however you prefer it. Make sure you're able to get that. Don't say, oh, I'll figure it out on the day we take a test. We don't want to try and figure it out on the day we take a test. We want to figure it out ahead of time. Okay. Questions on either of the two at the top? Alright, let's look at the next one. This one is written out just as a regular sequence. We're asked to find the 8th partial sum, which would be the sum of the first 8 numbers. So remember what we need. We need our A1, right, our starting term. We need our common ratio, and we need how many terms? What's A1? Good. Okay, what is our common ratio? Common ratio, just times 1/2, not divided by a half, not minus 1/2, just times 1/2. Don't say, there's a big difference between the two. Yes?
Divided by half is the same thing as multiplying by half?
No, dividing by half is actually multiplying by 2. It doubles it.
You're dividing by 1 over 2.
And then how many terms are we adding up?
You're dividing by
8. They literally said 8th partial sum, so that means 8 terms. So we're going to plug those all in. Sum of the first 8 numbers is 160, big fraction, 1 minus the common ratio to the 8th power over 1 minus the common ratio. Oops. Minus 0.5 to the 8th power over 1 minus 0.5. Alright, what'd y'all get? Yep, you did not get 1.25. What'd y'all get? Yes, 318.75, or as a fraction, 1275 over 4. Choose your favorite. 1275 over 4. All right. back to arithmetic. Arithmetic sequence. It has a 6th term of 35 and a 10th term of 43. And we want to find the 18th partial sum of the sequence. I feel like we had one the other day where we were just given 2 terms. And from those 2 terms, we were able to write.
The rise of her value.
Yes, we did. We found the slope between the 2. Yes. Ending. I feel like I need more room, but oh well. Okay. So we'll have 6th term is 35, so 6 comma 35. And then 10th term is 43. Okay, so we first found the slope between these, which the slope would actually be the common difference. So 43 minus 35 over 10 minus 6. 43 minus 35 is 8. 8 over 4 would be 2 for the common difference. Okay, and then from there, what did we find from there? Using your blank equation, just blank arithmetic equation, we plugged in one of the points as like the n and the an. It's basically an x and a y. N, a, n. So let me see. That'll give us 35 equals a1 plus n minus 1, which should be 6 minus 1, times the common difference of 2. So it would be, what, 5 times 2, which is 10. So our A1 is 25. Okay. And then once we know that, we can figure out what the equation is, because we're going to need the equation in order to figure out the last term. Because remember, for a partial sum for arithmetic, you need the first and the last term. Well, I know the first term, but I still need to find my last term. So my equation with everything plugged back in would be 25 plus n minus 1 times my common difference, which was 2. So I would simplify to 25 minus 2 plus 23. There's my equation. Okay. So going back and thinking about our arithmetic sum formula, we're going to need the number of terms, we're going to need the starting term, and the ending term. Okay, so we need number of terms, we need starting term, and we need ending term. What's the number of terms? 18, because they're asking for 18th partial sum. Good. Our A1, we actually already found it. What was the A1? 25. Good. And then our AN, which would technically be our A18, how are we going to find it? Yes, plug in 18 right here to the little equation we wrote. 2 times 18 plus 23, which equals 59. Okay. And then now that we have all these pieces of information, we can actually find the 18th partial sum. So sum of the first 18 numbers equals number of terms divided by 2. So it would be 18 divided by 2 times the first plus the last. 25 plus 59, 9 times 84, which is 756. You were? You almost got it?
Oh, no, I was just guessing.
Oh, what'd you guess?
256, I got the 56 right.
If that was the lottery, you'd win some money from that. Okay. The next one, we have one very similar to the solving for x one that we had on the front. So it says n equals 1. We're going to the x term. We can tell it's a geometric sequence because this is an exponential function. And again, we already know the sum. Okay. So I'm just going to write down the formula real quick. Sum of the first n numbers equals a1 times 1 minus r to the n over 1 minus r. So we're going to plug in what we can find from this. Okay. For Sn, what am I going to plug in? 1023 over 128. Okay, for A1, we can actually go find it. A1 would be 4 times 1/2 to the 1 minus 1. Oh my god, it's 4 again. I bet it's the eclipse. So it would be 4. Alright, so we know that's 4. And then we'll have 1 minus, what's our common ratio? 1 over 2, right, because it's basically the base of the exponent. I'm going to write mine as a decimal, though. To the power of x, yeah, because our n is our x. To the power of x over 1 minus our common ratio, 1 minus 0.5. Ooh, this one does not look fun to solve. Okay, what should we do first? Divide by 4, or multiply by a fourth, since I have a fraction on the other side. That at least gets rid of the fraction, or it gets rid of that part. Times 1/4, or divide by 4. 1023 over 512. Okay. On the other side now, do I need to write the parentheses anymore? No, you don't need parentheses anymore. 1 minus 0.5 to the power of x over, the bottom can simplify. What's 1 minus 0.5? 0.5. Okay. Now multiply by 2. That won't help. Multiply by 0.5. Yeah. Times 0.5. Yes, technically. Times 0.5. Okay, 1023 over 1024 now. Interesting. What type of equation is this? It's exponential, right. So we're trying to isolate the part that has the base and the exponent. Not yet, no, or never multiply by 0.5. Definitely subtract this 1. Minus 1. Yep, negative 1 over 1024 equals negative 0.5 to the x. Divide by the negative, right? So 1 over 1024. I'm going to go back and write that 0.5 as a fraction, so y'all can see we've actually done these type of equations before. Okay. Yes, we need to rewrite these with both of the same bases. These are both powers of 2. So we got to figure out 1024 is 2 to the what power? 2 to the 10th power? It is, yes. Alright, so I'm going to move it over here. So that would be on the left side 1 over 2 to the 10th power. On the other side, that's just 1 over 2 to the 1st power. How do we get them out of fractions? Danny doesn't know something for once. Do what? No, we don't need to log. Reciprocal. Yes, it is. It's just a reciprocal. Yeah. So remember, 1 over 2 to the 10th, you do the reciprocal and you would get 2 to the negative 10th. On this one, you would get 2 to the negative 1 to the power of x.
So then x equals negative 10?
Mm-hmm. Well, not x equals negative 10. X equals 10. You can cancel the two bases now because they're the same. And you would just get negative 10 equals negative 1 times x,
Whoa.
which means x equals 10. Not even an extraneous answer. Ooh, that one was fun.